Okay, so let's talk about rational functions here. So if you have a function f of x equals x squared over x squared plus 2x minus 8, a few different things that we want to talk about. Let's see if I can list those out. We want to first talk about the domain. Always want to be able to identify the domain of your function. You also want to talk about your asymptotes. So your asymptotes, you want to talk about vertical and horizontal. Excuse the cat, sorry. You want to talk about vertical and horizontal asymptotes. Other things that we want to talk about are x-intercepts, y-intercepts, and definitely some, I'll put int for intercepts, definitely some test points as well to see if we can figure out how to graph this. Okay. Alright, so let's go ahead and do this. Let's talk about the domain. In order to talk about the domain, we need to figure out where the denominator is equal to 0. So we're going to actually rewrite this as a factored function. So I'm going to go back here, we'll have f of x is equal to, still have the x squared on top, okay. But now on bottom, when you look at our denominator, this can be factored. X squared plus 2x minus 8 could be factored into the x plus 4, x minus 2. So again, we're just factoring that denominator, x plus 4, x minus 2. It's always easier to visualize that for the domain. So then you look at this, now that the denominator is factored, the domain, let's talk about what x cannot equal. X cannot equal negative 4, because that would give me 0 on the bottom. Also, x cannot equal to 2, because that would give me 0 on the bottom. Now again, when you're talking about that 0 on the bottom, what you're doing is you're simply just looking at this factor right here. If I plugged in negative 4, that would give me 0 on the bottom here. If I plugged in 2, that would give me 0 on the bottom here. So those are the things that we cannot have, which means if I were to ask you to write that domain in interval notation, this would be, oops, let's see if I can fit that here. That would be from negative infinity to negative 4, union negative 4 to 2, union 2 to infinity. So that's my domain. Okay, so now let's talk about some asymptotes. Definitely going to be able to try to find some asymptotes here. Okay, so first of all, let's talk about our vertical asymptotes. In order to find vertical asymptotes, your function has to be completely simplified. So if there's something to cancel, do so. In this case, there's not. So my vertical asymptotes are where the bottom is 0. So that's my x equals negative 4 and your x equals 2. In this case, the vertical asymptotes and domain match up. That's because nothing canceled. And then the horizontal asymptotes, remember vertical asymptotes are x equals a number, horizontal asymptotes are y equals a number. In this case, going back actually to look at the original is a little bit easier to identify the horizontal asymptotes. The degree on top is 2 and the degree on bottom is 2, so since they're the same degree, you can look at the coefficients in front. In this case, the coefficients each have a 1 in front, so my horizontal asymptote will be y equals 1 over 1, or simply just y equals 1. Okay, so that's what we have. We have our domain, our vertical asymptotes, and our horizontal asymptotes. I'm going to go ahead and actually graph that right now so we can get a good start on what the picture is going to look like, because asymptotes are really easy to graph. So I've got x equals 2, so there's my value of 2. You can draw a vertical line. I also had x equals negative 4, so there's my x value of negative 4. Draw my vertical line. And then I also had a horizontal asymptote at y equals 1. So the y value of 1, and then there is my horizontal asymptote. So that gets me a really good start on the picture. Of course, I then want to talk about some intercepts. So I'm going to go to the next page and actually try to visualize some of those intercepts. I'm actually going to rewrite the function one more time so we can see this. I have f of x equals x squared. Oopsies, sorry about that. Here we go, x squared, and then I had an x plus 4, x minus 2. So I'm going to talk about some intercepts. First of all, I'm going to talk about the y-intercept. So the y-intercept happens when you plug in 0 for x. If I plugged in 0 for x, I actually would get 0 as my y value. And then for the x-intercepts is when you actually set the top equal to 0. Now if I were to set the top equal to 0, I would also get 0 for my x-intercept. So in this case, they happen to be the same because it's the origin. Next thing I'm going to talk about is some xy values. Try to plug in some xy values, see if you can get an easier sort of estimate of where the picture is going to be drawn. So I'm going to take out my calculator here. Let's plug in a few numbers. I'm going to plug in -5. I'm going to plug in -1. I'm going to plug in +1. And then I'm going to plug in +3. So you might wonder where I got those values from. -5 was over here. -1 was right here. +1 was right here. And then 3 was right here. I'm just picking something on all sides of the asymptotes, things like that. That's all that I'm doing there. Okay, so I'm going to plug each of those in. So I'm going to plug in -5, -5 squared divided by, you can plug it into the factored version or the non-factored version. That's going to be up to you. You should get the exact same answer, so that's not going to matter. When I plugged in -5, I got 3.57. Okay. And then when I plug in -1, let's see what I get when I plug in -1. In this case, I got -0.11. If I plug in +1, see what happens when I plug in +1. And then I got, looks like -0.2. Okay, and then I'll go ahead and plug in +3. See what I get there. And then it looks like there I got 1.28. So those are just extra x, y points that you can plot. It's a good way to be able to connect the dots. So I'm going to go ahead and graph all of that. I've got the y-intercept, the x-intercept, plus those other 4 points. So let's see if I can graph that. I'll try to make my actual graph different from the asymptotes. So first of all, 0, 0 was both the x-intercept and the y-intercept. And then I had -5, 3.57. So it looks like somewhere right about there. Whoops, I did that wrong, sorry. -5, 1 to 3.57. Okay. And then I also had -1, -0.1. So not very much below that. Okay, and then I also got 1, -0.2. Also not very far down. Again, these are good estimates. And then 3, 1.28. So 3, 1.28. Alright, and then you can get an idea of how this is going to graph, because you can see it's not going to be able to touch the vertical asymptotes. It's going to be able to try to connect those dots that we have. Again, it's not going to cross the vertical asymptote. Alright, and that's what we have here. So this is going to give us right here, sorry about that, that was actually meant to connect. Alright, so this is our general graph for that rational function. So just as a recap, we talked about the domain, which we had over here. We talked about the vertical asymptotes, the horizontal asymptotes. And then we talked about y-intercept, x-intercept, plus some test points. Okay, so those are the main ideas in order for you to get this graph. So this is my graph of f of x. Ta-da!